Hey everyone, and welcome to the AI Research Roundup. I'm your host Alex, and today we're diving into some fascinating AI research. We'll be looking at a paper called UITARS, Pioneering Automated GUI Interaction with Native Agents. So, what this paper introduces is basically an AI agent named UITARS that learns to interact with computer interfaces, graphical user interfaces or GUIs, just by looking at screenshots. What's really interesting is that unlike many current agent frameworks that rely on heavily wrapped commercial models like GPT-4o, UITARS is an end-to-end model. And the paper shows it actually outperforms these more complex setups on several key benchmarks. Okay, so the researchers included this figure 1, to really show us how UITARS stacks up. Remember I mentioned it outperforms other models? Well, this figure visualizes that. On the left side, you see these bar charts showing the relative improvement of UITARS, both the 7B and 72B versions, over the previous best models, this state-of-the-art, across a whole list of benchmarks. And on the right, there's a radar chart comparing UITARS 72B directly against GPT-4o and Claude on several key tasks. It clearly shows UITARS pushing the boundaries, especially the larger 72B model. Okay, so going beyond those performance charts, this next figure, also figure 1, actually gives us a visual walkthrough of UITARS completing a task. It's a demo case, showing the agent helping a user find flights. What's really cool here is that for each step, you see not just the action the agent takes, like clicking a button or typing text, but also the agent's thought process right before it. It shows how it breaks down the task, handles errors through reflection and trial and error, and maintains consistency to finally book the flight. It really illustrates that end-to-end interaction we talked about. Okay, so building on that idea of UITARS being an end-to-end model, this next figure, figure 2, kind of zooms out to show the bigger picture. It illustrates the evolution path the researchers see for these GUI agents. It starts back in 2023 with simpler rule-based agents, moves through the agent frameworks we mentioned, like those using GPT, and then gets to these native agent models like UITARS around 2025. The figure suggests the future is heading towards active and lifelong learning agents, needing less human help and handling more complex, generalized tasks. Okay, so following that evolutionary path we just saw, this figure 3, dives a bit deeper into the core capabilities needed for these advanced GUI agents like UITARS. It breaks things down into key areas like perception, how the agent sees the screen using screenshots or even structured data, reasoning, distinguishing between fast system, 1-foot thinking, and slower, more deliberate system, 2-feet thinking for complex tasks, memory, both short and long-term, and finally, action, like clicking or typing. It also shows how these different capabilities are evaluated. Alright, so building on those core capabilities we just discussed, this next figure, figure 4, gives us a more architectural view of UITARS itself. It visually lays out how those components, perception, action, and that system 2 reasoning, all fit together within the model. What's new here is the explicit learning from prior experience block, showing how UITARS uses things like online trace bootstrapping and reflection tuning, learning from mistakes using agent DPO to continuously improve. It connects these capabilities to the actual interaction loop shown at the top, taking user queries and observations to produce actions. Okay, so going deeper into those capabilities we saw in the architecture, this next figure, figure 5, shows us concrete examples of the data used to train the perception and grounding parts of UITARS. Remember we talked about how it needs to see the screen? Well, this shows tasks like element description, question answering based on the screenshot, dense captioning to understand the whole view, and even state transition captioning to notice changes. It also includes task grounding, like figuring out the coordinates to delete an email. This is the stuff that helps the agent really understand the visual input and know where to interact. Okay, so we just saw some examples of the perception and grounding data used to train UITARS. This next table, Table 2, actually gives us some statistics about that data, specifically comparing the dataset the researchers created, which they label ours, against existing open source data. It looks at data for grounding, locating elements, and for multi-step action traces. What stands out is that their custom dataset, well, it has a higher average number of elements per image for grounding, 7.5 compared to lower numbers for open source. And importantly, their multi-step action traces are much longer on average, nearly 15 steps compared to around 7 to 9 steps for the open source data. So this really highlights how they focused on creating data for more complex interactions. So seeing those dataset stats really underscores how UITARS was built for complexity. I think the big takeaway is just how capable this agent is at navigating actual GUIs for complex, multi-step tasks, using its reasoning and learning abilities. This is a significant step towards AI agents that can genuinely operate our everyday applications and devices, moving beyond simpler benchmarks. It really opens doors. Well, that's all for this episode of the AI Research Roundup. Thanks for tuning in. I'm your host, Alex. Catch you next time.